right? And then plus remainder. Is that okay?
Yes.
So note one thing, this remainder is always less than divisor in this case, right? And that you can check, like divisor is 4, quotient is 31, and then you are adding plus 1. So 4 into 1, 4, 4 into 3 is 12, plus 1, so you get 125, which is equal to your dividend. Right. And if I get, for example, I'm getting a remainder 0. Let's say this remainder was 0, right? So I should like make it 124. If it was 124, then I will get my remainder 0. Is that okay? Because 1 is extra. Yes, Jaslyn. So if I take the dividend 124 and I divide this by 4 now, so I get 4 into 3 is 12, 0. Then I carry 4. 4 into 1 is 4. In this case, I get a remainder 0. So I can say that 4 is a factor of 124, isn't it?
Yes, ma'am.
Why I'm saying this? Because there's no remainder. It is completely dividing 124, so it is a factor. And 125, in this case, I was getting a remainder, so 4 is not a factor. So I think this thing is clear. Now let us come to polynomials. Okay, this is not the statement of the theorem, just like when a polynomial, I'm writing that when a polynomial px is divided by a linear polynomial, right? Linear means degree 1. Got it? Degree 1 polynomial. So what should happen in this case? If I divide a polynomial by a linear polynomial, what kind of remainder should I get? So the degree of the remainder in this case should be, because I'm dividing by a linear polynomial, degree 1. So the degree of the remainder should be 0. Is that okay? It cannot be equal to 1. It will be less than degree 1. Is that clear? Right? For example, I'm dividing something like this, x minus 5. This is my divisor. So you can see it has maximum power of x is 1. So this is a degree 1 divisor. Understood? So my remainder cannot have degree 1. The degree of the remainder will always be less than 1. So in this case, the next thing is 0. So the degree of divisor is 0. So I can get a divisor like this. For example, 2. It is degree 0 because x to the power 0. Is this okay? So
Yes.
ultimately, I'm going to get a constant number in these cases. I can get a number 4, simple 4. 4 is a degree 0 polynomial. Is that clear, Jaslyn?
Yes, ma'am.
Let me show you with the help of one example. Let us divide polynomials. So I'm just dividing this x to the power 4 plus minus 3x square and plus 2x plus 5. This is my polynomial px. I have taken some polynomial px. Okay. I want to divide this by this gx, which is x minus 1. This is my divisor. So let us perform a long division. Let's see what do I get. So you write your polynomial here, x to the power 4. Now there is no cube term. So can I write plus 0x cube, right? Right? Minus 3x square plus 2x plus 1. So in descending power of x, I have written. There was no cube term, so I have added, multiplied with a coefficient 0. So the term will become 0. And I want to divide this by x minus 1. So let us divide. So do you people know how to divide polynomial by long division? Was it done in your school?
No.
No. Okay, let us learn with the help of one example only. I want to show you something. That's why I'm doing it. Now, how do I divide? So see, here I have x, right? X to the power 1. And I want to get x to the power 4. So I'll multiply this thing with x cube, right, Jaslyn?
Yes, ma'am.
So x into x cube will become x to the power 4, right? Then minus 1 into x cube. Next number, this minus 1 into x cube will be minus x cube. So you write minus x cube below x cube. Now you do minus. So this term is anyway was not there. No, sorry. Okay, so 0x cube minus x cube. So you will get minus x cube, right? And this term will be minus because now you are, just 1 minute, you are subtracting. So first of all, you will change sign. So you will get a plus x cube. This term will be gone, right? So you change the sign because you are subtracting this thing. So sign will be changed. So you have a plus x cube. Then you drop down all the terms. Okay. Next, I have x cube. So I multiply this with plus x square. Is that okay? So x into x square will give me x cube. And then minus 1 into x square will give me minus of x square. Now you change the sign because you are subtracting. So this is gone. And minus 3 plus 1 means minus of 2x square. And then drop other terms. Plus 2x plus 5, right? Okay. Now this is x only. And I want minus of 2x square. So I multiply this thing by minus of 2x, right? So x into minus 2x becomes minus of 2x square. Then minus this minus 1 into minus 2x. So minus minus becomes plus 2x. Now you change the sign because you are subtracting. So this becomes 0. Now 2x minus 2x also becomes 0. And 5 minus 0, you get a remainder 5. Is that okay? I mean, just an example I'm giving you. I hope you have understood how I have done it. So I have got a remainder 0. Remainder 5, right? And 5 is what? It is a degree 0 polynomial. Now you check one thing. This was your divisor x minus 1, okay? Right? You put this divisor equal to 0, so you get x is equal to 1. Now you check the value of this polynomial at x is equal to 1. So you put 1 to the power 4 minus 3 into 1 to the power square plus 2 into 1 and plus 5. So what do I get? I get 1 minus 3 plus 2 plus 5, which is how much? Like 1 plus 2 is 3, 3 minus 3 gone, and only 5. So can you see something here? See, I am getting a remainder 5, right? Yes, nobody is speaking this way. How can I teach?
Yes.
Yes,
ma'am.
my remainder is 5, right? And if I'm calculating the value of my polynomial at x is equal to 1, again I'm getting 5. So I'm getting the same thing. Can you spot it?
Yes, ma'am.
The value of my polynomial at this particular x is also 5, which is actually equal to the remainder. Can you see this thing?
Yes, ma'am.
Yeah. So basically, this is the remainder theorem, that without performing this division, if I ask you that, for example, I'm dividing my px by this gx, okay? I mean, whichever is given to you. Px is being divided by gx. Can you tell me, like, what is the remainder? So you don't have to do this process of division. You can directly say that the remainder is equal to the value of the polynomial at, because gx is actually equal to x minus 1, yeah? So the value of polynomial at x is equal to 1 is your remainder. So you can directly say this thing. I hope it is clear.
Yes.
We will do questions, then it will be more clear. Now I want you to write at least the statement of the theorem, which is called the remainder theorem. Then we will do question. So let Px be any polynomial of degree 1 or greater than 1. Okay, and let's say A be any real number. Real number mean it can be fraction, it can be decimal, it can be irrational, any real number, right? So these are the two things we have supposed. Now, if Px is divided by x minus a, right? Then the remainder is equal to p of a. That means the value of the polynomial at a. Is this clear to both of you? Like what is
Yes, ma'am.
the theorem, right? So yeah, so basically, okay, let us take one example to understand it. I am giving you a polynomial which is x to the power 4 minus 3x square plus 2x and plus 1, right? And it is divided by x minus 1. Find the remainder. So you don't have to perform the division. You simply write that your gx, like your divisor, gx is basically just a name. You can write gx, you can write fx, mx, lx, whatever you wish, right? Just a name you are giving to this one, x minus 1. Is that okay?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
what we do it, we put this polynomial, I mean the divisor. This is actually your divisor. So we put your gx equal to 0. So that means x minus 1 equal to 0. So that gives you x is equal to 1, right? So from remainder theorem, required remainder is actually equal to the value of this polynomial at 1, right? This value. So you simply put 1 in your polynomial. This is 1 to the power 4 minus 3 into 1 square plus 2 into 1 and plus 1, right? So that gives you 1 minus 3 plus 2 plus 1. So that means 2 plus 1, 3 and 1 only. So this is your remainder. So I hope you have understood what is the remainder theorem now.
Yes, ma'am.
Okay. So we will come to exercise, but before that, let us come to factor theorem also. Right. Now, first of all, write what is a factor theorem, then I'll explain it. Factor theorem. Let Px be a polynomial of degree one or greater than one, right? And A, B, any real number, right? Same thing. So far the statement is same as before. A, B, any real number, right? Now, such that there can be a case where you are getting, where you are getting the value of the polynomial at this particular A to be 0, right? If this is the condition that the value of the polynomial at A is equal to 0, what does it imply? So it implies that then x minus A is a factor of Px. Okay, now try to understand it first of all. We will do the proof also, but let us understand the statement. See here, what is happening? You are getting P of A is equal to 0, right? P at this value is equal to 0. What does it imply from remainder theorem? That means your remainder is 0. Yes, Zanab. The value of P
Yes.
at A is what? It was actually your remainder, isn't it? From remainder theorem. This was
Yes.
your remainder. So your remainder is actually equal to 0 in this case, right? So basically, your polynomial Px is now x minus A into some other, let's say Qx. So basically, the polynomial has been broken into two factors. One factor is this, another factor is this. Is that okay? There's no remainder. So we can see that x minus A is one of the factor of the polynomial. Is this understood?
Yes.
So if remainder is 0, so remainder is 0 when? So it will not directly say that the remainder is 0. It will say that P of A is equal to 0. Now you already know what is P at A. P at A is actually your remainder. From the remainder theorem, you know this thing. So that means if P of A is equal to 0, that means there is no remainder. So ultimately your Px is x minus A into some quotient. So we can say that x minus A is one of the factor of the polynomial. Is this clear?
Yes.
Yes, Jaslyn, is that clear?
Yes, ma'am.
Okay, let's do a proof of this, just 4-5 line proof, because it's written in the syllabus, that proof of factor theorem. So, let us do. So first of all, let few things, right, for the proof. So let us assume a polynomial. So let Px is a polynomial of degree 1 or greater than 1, right? So we have assumed Px. Then let us assume number A, which is any real number, right? Any real number. Let A is any real number such that we have taken A such that the value of this polynomial at this A is actually equal to 0. So this is the condition here. So basically, we have to show that x minus of A is a factor of Px, right? This you have to show. Right. So how we will show this? Let Qx be the quotient. It is just a name I'm giving, right? Let us denote the quotient by Qx. Let Qx be the quotient. So from remainder theorem, we know that by remainder theorem, what do we know? We know that when Px is divided by x minus a, right? It gives remainder equal to the value of polynomial at a. This is from remainder theorem, we know, right? So therefore, my polynomial is actually written like this. So I'm dividing this by x minus a, which is the divisor. And I'll get some quotient here, right? And plus remainder. So remainder is p of a, right? Because we don't know the value of the remainder. So what should I get? I will find the value from the remainder theorem, right? This is my remainder. Is that okay? Now, here in this situation, your p of a is actually equal to 0. There is no remainder. So that means p of x is equal to x minus a into qx only. Why? Because p of a is equal to 0. So now you have seen that p of x can be written as x minus a multiplied by some quotient. So what does it imply? It implies that x minus a is a factor of px. That's it. See, the same thing which I explained before, it's just a proper way of writing. That's it. Yes, Zanab, have you written?
Yes, ma'am.
Jaslyn, have you written?
No, ma'am. Finished, ma'am.
Okay. Quick revision of both the theorems. Suppose we are dividing px by x minus a. Let's say we are doing this. Okay. So there can be two possibilities. Try to understand before you write, then I'll give you time to write. There can be two possibilities here. What are the two possibilities? That we get remainder, right? And we get no remainder. Is that okay? You are doing division, so either you can get a remainder or there is no remainder. These are the two possibilities. Okay. So if there is no remainder in this case, so from factor theorem, we can say that x minus a is a factor of px. Understood? Is that clear? So this theorem will be applied when there is no remainder. Now, if we get a remainder, so if we get a remainder, that means that x minus a is not a factor. Is that clear?
Yes, ma'am.
Okay. I think this is clear. So in this case, x minus a is a factor. In this case, x minus a is not a factor. But because we are getting a remainder, so we can ask one thing, that how much is the value of this remainder? Right? How much is my remainder? That question I can ask. Now this can be answered from remainder theorem. Understood? So from remainder theorem will give me its answer. The remainder theorem will say that your remainder is actually equal to the value of your polynomial at a. Is that understood?
Yes, ma'am.
So I think that makes the picture very clear in your mind. Let us proceed with exercise 2.3 now. So 2.3 has only 3 questions. Exercise 2.3. First question. Now find the remainder when this thing is divided by this. So first of all, you write down how much is your px. Px is equal to, because this is a polynomial in x, so I'm denoting by px. X cube plus 3x square plus 3x plus 1, right? So first, it is divided by, so let's give it some name. Let's call it gx. So gx is equal to x plus 1, right? So px is being divided by gx. You have to tell how much is the remainder, right? So how to solve it? You first of all, you put your gx is equal to 0. So that implies that x plus 1 is equal to 0, and that gives you x is equal to minus of 1. Is that okay? So from
Yes, ma'am.
remainder theorem, remainder is equal to the value of the polynomial at this value which you have found, right? X minus 1. So which is equal to p, not p, put minus 1 in your polynomial. So that is equal to minus 1 whole cube plus 3 into minus 1 whole square plus 3 into minus 1 and plus 1, right? So this is 3 times, like minus 1 into minus 1 into minus 1. So 2 minus will become plus and 1 minus will remain. So minus of 1, right? Plus. So this will be 3 into only 1. Minus 1 into minus 1, minus minus will become plus. Plus, okay, so now this is plus minus minus 3 and plus 1. So this is again minus 1 plus 3 minus 3 plus 1, right? So that you can easily see 1, 1, 3, 3. So you are getting 0. Please check the answer in the book. What are you getting here? Yes, at the back of
0,
NC.
ma'am.
Yeah. So my remainder is 0. So can we say that gx is a factor of px?
Yes.
Yes. We don't have to write, but I mean, it's clear from here that gx is a factor of px. Okay. Second part. Okay, now your gx is x minus of half. So again, put your gx is equal to 0 first of all. So that means x minus of half is equal to 0. And this gives you x is equal to half, right? So from remainder theorem, your remainder is equal to, okay, what was your polynomial? I forgot it. Px is equal to x cube plus 3x square plus 3x plus 1, right? So remainder is equal to value of this polynomial at half. Clear? So you put half everywhere. So half whole cube plus 3 into half square plus 3 into half and plus 1, right? Jesslyn, is that okay?
Yes, ma'am.
Right. So this is 1 into 1 into 1 will remain 1. 2 into 2, 4. 4 into 2, 8. So 1 by 8 plus. So this is 3 into 1 upon 4, right? And plus this will be 3 by 2 plus 1, right? So 1 upon 8 plus 3 upon 4 plus 3 upon 2 plus 1. So you are adding fractions. What will you do now?
LCM.
Exactly. So anyway, LCM is 8, but you can always do it to avoid mistakes because you have a 1 here, right?
Yes.
So 2 into 4 2 and 1, then 2 into 2, 1, 1, then 2 into 1, 1, 1. So till you get all 1. So LCM is 8. So take it 8. Now this will go one time, right? So 1 into numerator. 1 into 1 is 1 plus. So this is go 2 times. 4 into 2 is 8. So 2 into 3 is 6 plus. So this will go 4 times. 4 into 3 is 12 plus. This will go 8 times. Like LCM will go 8 times and 8 into 1 is 8. Sorry, Jocelyn? Any confusion?
Ma'am, I got confused in the third step.
This one?
Ma'am, for the LCM.
Okay. So this is 1 upon 8 plus 3 by 4 plus 3 by 2 plus 1. So far, is it clear?
Yes, ma'am.
Okay. Now, because I don't have anything here, I can put 1, right? Now, I have taken LCM. So, LCM is 2 into 2 into 2, which is equal to 8. So, how do we take LCM? Now, put here. So, now we actually see the table, like this is your LCM 8, right? So, in the denominator, how many times is it multiplying? So, 8 into 1 is 8. Is that okay?
Yes, ma'am.
So this 1 will be multiplied with the numerator. Understood? Plus. Now 4 into 2 is 8, right?
Yes, ma'am.
Yeah, the LCM is 8. So 4 into 2 is 8. So that 2 will be multiplied with the numerator. That okay? Plus. Now 2 into 4 is 8, right? So this 4 will be multiplied with 3. And similarly, 1 into 8 is 8. So 8 will be multiplied with the numerator. Now is this clear?
Okay, ma'am. Thank you.
So this will be 1 plus 6 plus 4 into 3, 12 and plus 8 and then divided by 8. Now you add all the numbers. Yes, how much you are getting?
27.
Yeah,
27.
okay, 27 divided by 8. So you can leave it in fraction if you wish. 27 by 8 is your remainder. Okay, done.
Yes, ma'am.
Right, next. Now please give it a thought and tell me, what should I expect as the answer? Like you have some px, which is actually how much? X to the power 4 plus 3x square plus 2x plus 1. Please check, right? This is your px. Then this time your gx is simply x. So you are dividing this polynomial by x. So can you do it? Just give it one or 2 minutes. Please try yourself.
Ma'am,
Yes.
in px, x to the power of 4 or x cubed it is.
Oh, sorry. Yeah, I was saying, please check in the book. I didn't see in the book. 3x cube plus 3x square plus, sorry, it was 3x, right? plus 1.
Yes.
Yeah. Anyway, as I told you, the same way do it, right? So put gx is equal to 0. Clear? That means your x is equal to 0. Simple, you have got the value of x. X is equal to 0, right?
Yes.
So from remainder theorem, okay, I'm writing in short, your remainder is equal to, please don't write like me, write complete. Value of polynomial at x is equal to 0. Is that okay?
Yes.
Yeah, simple. Now you put 0 everywhere in place of x. So you have 0 to the power 3 plus 3 into 0 to the power square plus 3 into 0 and plus 1. So 0 cube means 0. Something multiplied by 0 is again 0 plus again 0 plus 1, right? So you get 1 only.
1.
Now next one, fourth part. How much is your gx? Gx is x plus pi. Clear? So put gx is equal to 0. So that means put x plus pi is equal to 0, right? What does it give you? It gives you x is equal to minus of pi. Please see. When something is written like this, x minus 5, right? That means you're going to get x is equal to 5, right? If it is written as x plus 5, so you're going to get x is equal to minus of 5. Is that clear?
Yes, ma'am.
Yeah. So basically at this value you have to find. So again from remainder theorem, your remainder is actually equal to value of polynomial at minus of pi. Is that okay? That you can write. So let us find this is equal to, so minus of pi whole cube. In place of x, write minus pi, right? Plus 3 into minus pi whole square plus 3 into minus of pi and plus 1. Clear? Okay. Now, see, this is minus pi into minus pi into minus pi. So 2 minus will become plus and 1 minus will remain. So you get minus of pi cube, right? And here minus minus will become plus. So 3 pi square and plus minus minus 3 pi and plus 1. Now because all the terms are having different degree, you cannot add them or subtract them. Please remember, for addition or subtraction, the degree of the terms has to be same. Clear? So this is the remainder. This is the answer. Now try to understand this thing. What I'm saying is, Jaslyn, look here. Okay, just note it down. Give me 1 minute. Yes, written. Now try to understand this thing. Yes, Jaslyn, Zana.
Yes, ma'am.
Yes,
Okay.
ma'am.
If the terms are having the same degree, for example, I have a term like 2y square and I'm adding it with 6y square. So you can see both are degree 2 terms. So I can add and I can get 8y square as the answer. Understood? If it is 2y square plus 6y cube, This is the answer. I cannot do anything here. Understood?
Yes, ma'am.
Because y square is something else, y cube is something else. So how can I add them? It's like, for example, in a basket, like you have a basket, right? And you have, let's say you have 2 apples in it, and then you have 6 oranges in it, right? Now I ask you to add them. Simple, I'm saying just add them. So what will you give me as an answer?
8.
8 what? I mean 8 apples or 8 oranges? Right? Got the point? 2 apples will remain 2 apples. They will not convert into oranges, isn't it? So the answer will be 2 apples plus 6 oranges. That will be the answer, isn't it? How can you mix? I mean, you can say 8 fruits. That is okay. So you are using a third unit. That is fine. But in terms of apples and oranges, you cannot add them. You cannot say 8 oranges, but 2 were apples, right? You cannot say 8 apples because 6 were oranges. So different things you cannot add together. If the things are same, this is also apple, this is also apple. The answer is 8 apples. Understood? Yeah.
Yes.
So please remember this thing. Let's come to next question now. Question number 2, first part. Okay, find the remainder when this is your px, which is x cube plus 3x square plus 3x plus 1 is divided by, so first part, your gx is this 5 plus 2x, right? And you have to tell me the remainder. Same type of question. So I'll do 1 or 2 parts. So put gx is equal to 0, clear? That means 5 plus 2x is equal to 0. So take 5 on the other side. So 2x is equal to minus of 5. Is that clear?
Yes.
So x is equal to minus of 5 by 2. So first of all, you have to find what is the value of x. So from remainder theorem, your remainder is equal to the value of polynomial at this particular x, that is minus 5 by 2. Right? So your remainder is equal to, let me do it here. So put minus of 5 by 2 whole cube plus 3 into minus of 5 by 2 whole square plus 3 into minus of 5 by 2 plus 1, right? Okay. So minus, 3 times. So 1 minus will remain. 5 into 5, 25, 25 into 125, right? Divided by 8. Then plus 3 into 2 minus, they will go 5 into 5, 25 divided by 4. Clear? Now minus plus will become minus. 3 into 5 is 15 and divided by 2 and then plus 1. Clear? So I get minus of 125 by 8 and plus 3 into 25. 25 plus 25, 50. One more 25, 75 by 4. Minus 15 by 2 plus 1. Again, same numbers. You have take the LCM, you will get 8. But please take it, okay? Sometimes you may make mistakes. So take LCM, you will get 8. So again, Jaslyn, now see here. So this is actually 8 into 1 is 8, right? So numerator will be multiplied only by 1. So it will be minus 125. Okay, let's do it. Plus. Now 4 into 2 is 8. So this 75 will be multiplied by 2. Please use brackets always. Then minus. Now this is 2 into 4 is 8, right? So this 15 will be multiplied by 4 plus. Now you don't have anything, so put a 1 here. So 1 into 8 is actually 8. So this 1 will be multiplied by 8. Is that okay? The
Yes, ma'am.
numerator will be multiplied. This is minus of 125 plus 75 into 2 is 150 minus 15 into 4. So 15 plus 15, 30, and 30 plus 30, 60. And then plus 8 divided by 8. Okay, now you please do it and tell me what you are getting. Okay, just add the negative numbers together, right? So 125 and 60. 5, 8, minus of 185 because both are minus. So minus of 185, right? And plus 150 plus 8 will be 158 and then divided by 8. Is that okay?
Yes.
Now, obviously, one number is plus, one is minus. So you have to subtract and the sign will be of greater number. So it will be having a minus sign. So how much is 185 minus 158? 15 minus 8 is 7.
27.
27. So minus of 27 divided by 8 is the answer. Right?
Yes.
Yes, Jaslyn written.
Yes, ma'am.
Okay. Next part now. Second. So find the remainder when this thing is divided by. So px is given. Which is x cube and minus of ax square plus of 6x and minus of a. This is the question, right? This is question number 2, I think. Am I at the right question? Yeah.
Yes.
Okay. And you have to divide this by this. So my gx is what? X minus of a. Find the remainder. Same problem. Put gx solution. That put your gx is equal to 0. So that means x minus a is equal to 0. That gives you x is equal to a, right? So we can say from remainder theorem, your remainder is equal to the value of the polynomial at x is equal to a, right? So wherever you have x, put a. So a cube minus a into a square plus 6 into a minus of a, right? That becomes a cube minus a square into a becomes a cube plus 6a minus of a. So a cube minus a cube, that becomes 0, right? Plus now 6a minus a, because both are a, you can subtract. So 5 of a, and that becomes 5 of a. Third question. So you have to check whether 7 plus 3x is a factor of this. So your px is actually this 3x cube plus 7x, right? And then your gx is this 7 plus 3x. So you have to check whether gx is a factor or not. So how will you check? If your remainder is 0, then gx is a factor, isn't it? Yes, Jaslyn?
Yes, ma'am.
How do you know
Yes,
that
ma'am.
gx is a factor? If the remainder is 0, then gx is a factor. And how do we find remainder? From the remainder theorem. So same thing you do, that put gx is equal to 0 first of all. This will give you the value of x. So 7 plus 3x is equal to 0. That means 3x is equal to minus of 7 and x is equal to minus of 7 by 3, right? So from remainder theorem, your remainder is equal to the value of polynomial at minus of 7 by 3. Clear? So let us find out. So remainder is equal to, now in your polynomial, put this minus of 7 by 3 whole cube plus 7 into minus of 7 by 3, right? So 3 into, now power 3, so 1 minus will come, right? And 3 into, okay, can you multiply? Now 7 into 7 is 49, that I know, right? So can I write this 49 into one more 7, right? And divided by 3 into 3 into 3, right? So 1, 3 will actually cancel out. And then plus minus minus, 7 into 7 is 49 and divided by 3, right? So you multiply the numerator, 49 into 7 is how much? 63, 6, 7 into 4 is 28, and 3 is 31. Sorry, wrong, I have done. 49 into 7. Now 7 into 9 is 63, carry 6. And then 7 into 4 is 28, and 6 is how much? 34. So 343 I'll get. So minus of 343 divided by 9, and then minus of 49 divided by 3. Is this clear? Then Jaslyn, is that clear?
Yes, ma'am.
Okay. Now you have to take LCM. So take LCM of 9 and 3. So 3 into 3 and 1, then 3 into 1 and 1. So LCM is 3 into 3, which is 9. So your LCM is 9, right? So see, this is one time it will go, Jaslyn, right? So 1 into numerator will remain same, 343 minus. So this will go 3 times, right? New
Yes, ma'am.
3 into 3 and 3 into 49. So multiply 49 by 3. So 3 into 9 is 27, carry 2. 3 into 4 is 12 and 2, 14. So 1 to 47 I get. Now both the numbers are minus, so they will add up, right? Minus minus become plus, but with a minus sign. So please add them. So 7 and 3 is 10, carry 1. 4 and 4 is 8 and 1, 9. And 3 and 1 is 4. So I'm getting minus of 490 divided by 9, right?
Yes.
Right. So ultimately, I want to see whether my remainder is 0 or not equal to 0. So this is actually not equal to 0, right? I'm not getting a
Yes.
0. So therefore, I can say that gx is not a factor of px, right?
Yes.
So therefore, you will write that your 7 plus 3x is not a factor of px. Okay, before doing next, okay, we will be doing the exercise in the next class. But I want to ask something from you people, like very honest feedback I need. Do you find my speed too slow or too fast? Or please tell me honestly, Zainab, I want to ask you.
No, ma'am, it's not too fast,
Hmm.
but it will be good if you can slow down a bit. Actually.
Slow down. Okay.
Yes.
Okay, fine. And what about you, Jaslyn?
Yes, ma'am. It will be like better if you get like a little bit
Okay.
slow down.
Okay. Yeah, so you can tell me honestly, it's okay. Like, fine. So I'll just try to slow down a little bit. So sometimes, you know, when we teach regularly, so sometimes we skip steps. I, with the experience teacher starts to believe that student will complete it at least, but okay, anyway, I'll just try to do all the steps. So far, is that okay? Like, are you able to understand?
Yes, ma'am.
Yes, ma'am.
Okay. So anyway, please, if you have some other book with you, practice some questions, at least 5 or 6 questions. You practice as a homework. Let me give you a few questions in the homework, just 1 minute. You have to complete it. Okay, just try this question that if the polynomial, right? So I'm not writing that if this polynomial, which is ax cube plus 4x square plus 3x and minus 4, right? Okay, and another polynomial. There is one more polynomial which I can denote by fx, let's say. This is another polynomial which is x cube minus of 4x plus a, right? Okay. Both the polynomials leave the same remainder. When divided by x minus 3, right? Find the value of a. Do you think you can do it? See, this is very simple. Just don't get panic. Look here. This is one polynomial, right? You are dividing
Yes.
this thing by x minus a, right? So find remainder. All right, by remainder theorem. Okay.
Yes.
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 This is another polynomial which is also divided by x minus 3. So find another remainder. Okay.
Okay.
Let me call it remainder dash something, right? This is one remainder, this is another remainder. Okay. So they both the remainder are same. So ultimately you have to equate both the remainder. Understood?
Yes.
See, I don't know what will you get, but for example, you are getting something like this 2 minus a, this remainder, right? Let's say you're getting 3 as this remainder. So you put 2 minus a is equal to 3, and then you do 2 minus 3 is equal to a, and minus 1 is equal to a, or a is equal to minus 1. So that way you have to find the value of a. Okay? So you just have to equate both the remainders. That's it. So I don't know what is the answer. This was just an example I have taken. Okay, just few simple one I am giving you. Let's say my fx is this 4x cube and minus 12x square plus 14 of x minus of 3. Okay, and this is your gx, which is 2x minus 1. So you have to find the remainder. Let's say 1 and one more I want to give you. Let me give a simple one. Fx is x cube plus 4x square minus of 3x plus 10, and then gx is equal to x plus 4. Okay, one more. I want you to practice with the LCM calculation. So your fx is equal to 3x to the power 4 plus 2x cube, right? Minus x square divided by 3 minus x upon 9 plus 2 by 27. Clear? And your gx is equal to x plus 2 by 3. So this one will require a bit lengthy calculation. But please try to solve it. It will give you a good practice at your calculation at least.